Hi. So we have already studied about the inverting adder concept. Now I go for some problem on the inverting adder concept. I'm just developing, composing one problem in here, and we just solve it. The things is that what I'm doing, I'm just consider this is R1, this is 5k, this is 10k, and this R3 equals to suppose 15k, and again this is equals to is the 5k. Okay, so and if it is happened, then if it is v naught, then I am asking you that what is the expressions, what is the expressions, what is the relations between the v1 and v naught and v1, v2, v3, that is the expressions representations. So for that reasons, very easily we just do this particular math, that v3 by r3 is how much, r3 is the 15, and next is that r3 is the 15, then v2 by 10, and v1 by 5, which is minus, which is equals to uh, v naught by rf is how much, 5. Okay, rf is also 5. So these are 5, 5, 10, 15. Okay, I am just multiplying with I'm just multiplying with the, with, here it is, that is the, I'm just multiplying with 5 and 5 both sides, multiplying with 5, multiplying with 5 for our simplicity. It's just representing that v3 by 3 plus, because 5 is here, 3, 15 here, this is 3, and this is v2 by 2, and this is v1, which is equals to v naught. Okay, so this is the expressions relations, we can change it according to that again. So it can also possible, we just multiplying with that 6, that is also possible. So this type of problem we can representing. Or suppose another problem, I just find out that suppose there is suppose there is 10k, there is 5k, there is 15k, and here it is 1 volt, it is 2 volt, and it is 3 volt, then what will be the v naught? So for that point of view, again I am go for this particular equations, like that v naught by rf, which is equals to minus of v1 by r1 plus v2 by r2 plus v3 by r3. So you just put this value, that v1, and I just want to know that v naught equals to how much. And for that point of view, if it is 5, as it is the 5, that I'm just put this value is the 5, that rf is here, this is minus, and this is v1 is how much, this is 1 by r1 is how much, v1 is how much, v1 is v1 is 2, 2 volt. Okay, 2 volt, and r1 is the 5, 2 by 5, plus v2 is 1 volt, and r2 is 10k, 1 by 10, and then plus again, and this is the v3 is the v3 is the 3 volt, so 3 by, this is r3 is equals to 15k. So like that way, if I'm calculating this value, this v naught value is calculating. So these are the simple math operations, simple mathematical calculations through this adder. This type of problem is very important for us. Thank you very much. Hi. So in the operational amplifier, we have already habituated this operational amplifier and different circuit we have studied. In this module, we just study about one very important circuit of the operational amplifier and which is required for different circuit and signal analysis type circuit of the operational amplifier. So and first we just go for the effect of this circuit, then we can understand what can I done, how the concept is coming, these things. So first we just draw one circuit, that is, and you say it is what kinds of circuit of is, and then we will start. So this is V1 suppose, and this is R1, this is RF, and this is V0. This is inverting input terminal, this is in non-inverting input terminal. As the voltage is passing through this inverting input terminal input, and it is the closed loop, so I think you can understand it is the inverting amplifier circuit. It is the inverting amplifier circuit. Now I have one questions. What I am doing, I am just changing this circuitry, and just I am changing this particular circuitry just like that way. I am just introducing one capacitance in here, a reactive capacitance in here. If I am introducing the capacitance in here, then what will happen? Then what will happen? This is our questions. So analysis this particular things, the same concept we have introduced. The current in here, this input side, and current in here in the output feedback side, both are same. That means the current in here, that is II, and the current in here, that is the IF, both are same. This is the II current, and this is the IF current. Okay, very good. And I'm just representing the current, that is II. Apart from that II, this is IC, because this is the capacitive current. This is the capacitive current. Okay, very good. And so for that reasons we can represent it as a IC, that is the capacitive current. Okay, very good. Now a very interesting fundamental themes I am coming, and I know that it is always negative. I just represent it as a negative. Okay. Now a very fundamental things is coming here. This is IC and this is IF, and both are equals. This is equals to minus things. That means how we can approach this particular circuit, we have to know about to analysis the circuit like that way. So as the inverting input terminal, inverting amplifications concept, we just equivalency of this circuit and this circuit, this current and this current, like that. So we just introduced, and here it is IC, so we have to find out the IC, what is the value of IC. I hope you all of you know about this particular equations, that is the Q equals to CB. This is the capacitor equations. This is the capacitor equations. Q is the charge, amount of the charge. C is the capacitance, the capacity of start storage, and which is multiplying with the voltage. Q equals to CB, and Q equals to CB representing the charge amount of any kinds of capacitance, charge amount of any kinds of capacitance. So as it is the charge amount of any kinds of capacitance, so we just go for the next step of it. I'm just differentiate these things. I'm just differentiate these things, and if it is differentiate, and here we can get that dv dt. Okay, so this is the dq dt, which is equal to c dv dt. Okay, this voltage is basically the capacitance voltage. Inside of the capacitance, what voltage is there, that is the voltage, this v. Okay, so dq dt, we know that dq dt is equals to, this is equals to ic, and c is the capacitance value, and then dv dt, then dv dt. Ic equals to c dv dt. Okay, this Ic equals to c dv dt. what is the value, what is this thing, this is the V, this is the V, that means inside of the capacitance what is the voltage of there. Okay, so IC is here, you show C equals to dVdt is here, very good. And this V, what is the value of this V, you show this V is basically nothing, that is IC equals to C dV minus 0 dt. Why 0? Because you saw this is the virtual ground, that is 0. This is V1, sorry, I am again sorry, that is V1 dV dt. Okay, V1 0 minus 0. That's why we can write it down that IC equals to C dV1 dt. C dV1 dt. IC equals to C dV1 dt. IC equals to C dV1 dt. This is IC equals to C dV1 dt, which is equals to minus IF. Minus IF is what? Minus V naught by RF. Minus V naught by RF. This IF equals to minus V naught by RF, and this V naught minus 0 by RF. V naught minus 0 by RF. That means V naught by RF. So we can representing like that way. dVi dt, which is equals to V naught equals to that. V naught equals to output voltage. This V naught equals to minus RF C dV1 dt. We can represent it like that way. V naught equals to minus RF C dV1 dt. That is one of the very important equations, that is V naught equals to minus RF C dV1 dt. You show the input voltage which is coming in here, which is differentiate and give the output voltage, that is V naught, which is given in here. Now if I am designing it like that way, suppose this RF equals to 1 by C, RF equals to 1 by C, suppose considering and actually considering means we are designing like that way. So that means RF equals to 1 by C, that means RFC equals to 1. It may be designed because RF and C it is in our hand. If I am changing the RC value and RF value, then automatically RC equals to 1. Then we can represent the equations like that way. We can represent the equations like this way. We can represent the equations like this way, that V naught equals to minus dVi dt. Whatever the input I am giving, that is differentiate and give the output, that is V naught, which is equals to this. Whatever the input I am introducing, that is differentiate, giving the output, but it is the minus sign. But we can change this minus signs also by using the sign changer circuit or inverter circuit, simple inverter circuit. So that is called you show the input voltage is given here, which is differentiate. Operational amplifier is the amplify, and also operational means it have some mathematical operations. It can capable to do some mathematical operations. So this is you show the operational amplifier able to differentiate and give the output. So we can represent it like that way. It is the differential amplifier circuit. This is the differential amplifier circuit. Thank you very much.